Okay. Now we proceed to the confidence interval for a proportion. When it's involved with proportion, so actually if your question has a percentage of fraction or ratio, so you need to find confidence interval for a proportion. Okay, we have previously used the ratio scale of measurements such as income, weight, distance, and age. What if we use proportion nominal scale of measurements such as percentage? Okay, so this is the example for confidence interval in proportion. So for instance, a recent survey indicates that 72 out of 100 people favor the new government. The sample proportion is therefore 72%. So means that this one is X divided by N. So our X, this one is our N, sample size. Total is 100. Okay, so if we let P represent the sample proportion, X the number of successes, and N the number of items sampled, we can determine the sample proportion as follows. So P equal to X divided by N. Actually this one is same with the probability of success lah. Okay. To develop a confidence interval for proportion, we need to meet following assumption. So first, it should be binomial condition, which is we have only two possible outcomes, which is fail or failure, or false or true. Okay, and then the value of n pi must be greater than 5. Okay, pi ni actually is the percentage of successes in the population. So actually this one you need to replace this term with p, because pi actually we have the value in mathematics, so it's not suitable to use symbol pi in this value. So actually np must be greater than 5, and then n1 minus p should be greater than 5, where p is the percent of successes in the population. This allows us to invoke the central limit theorem and employ the Z distribution as a part of the confidence interval. So this is the formula for confidence interval for a population proportion. Okay. Take a look for example 5.9. Two engineering society propose a merge. A random sample of 2,000 members will be asked if they support the merge. So this is our N, and then 1,600 members plan to support the merge. So this is our X. According to by law, merge must obtain at least 3/4. At least 3/4, mestilah member vote. Okay. What the estimate of the population proportion? So you need to find the value of P. So your P is X divided by N. So our X is 1,600 divided by 2,000. So you get the value is 0.8 or 80%. And then question number B, construct a 95% confidence interval. So just substitute the value from this side. Okay, so our Z 95% is 1.96. P is 0.8. 1 minus 0.8 divided by 2,000. So we get this interval, confidence interval. Okay. Question number C, can it be concluded that the merge proposal will pass? Okay, so the confidence limit are between this number. Okay, since the lower confidence limit is greater than 0.75, which is 3/7. Okay, so actually they pass because according to the law, 3/4 must be vote the merge. Okay, so this one, since this limit is greater than 0.75, so we can say that the merge proposal is pass. Okay. The last subtopic, in this chapter, Finite Population Correction Factor, FPC. Okay, the population we have sampled so far have been very large or infinite. What if the sample population is not very large? Okay, a population that has a fixed upper bound is finite. It can be rather small or very large. For example, for small, example is student in a class. Okay, and then example for the large population is engineering student in Johor. So we can see that the difference between these two populations. Okay, for a finite population, where the total number of objects is n and the size of the sample is small n. The following adjustment is made to the standard error. So this adjustment is called finite population correction error. So standard error of the sample mean using the correction factor is standard divided by n, square root n minus n minus 1. Okay, standard error of the sample population. If you use sample population, so you need to use this formula, this one for sample mean. Okay, so actually you need to differentiate between these two things lah. Okay, it should be noted that the correction factor is significant only when we sample without replacement for more than 5%. So actually you need to test first, and divided by capital N should be greater than 0.05. So if your condition meets the requirement, so you can use FPC. Okay. It is needed because the central limit theorem does not hold and the standard error of the estimate will be too big. Okay, in the basic term, the correction factor captures the difference between sampling with replacement and without replacement. Okay. A university requested donation from 250 international alumni members. A survey of 50 international alumni revealed the mean donation is 450. Okay, so our N is 40 and then our capital N is 250. Okay, first you need to identify whether the value is 0.05 or not. So since this one is 0.16, it's greater than 0.05, so we can find the finite population correction factor. Okay, construct 95% confidence interval, so our Z value is 1.65. Okay, since this one we use sample mean. Okay, so use this formula, substitute the value, then you get the answer. Okay, so this is the conclusion. So the confidence limit of $432.03 and $467.97. It can be concluded with 90% confidence that the population mean donation falls within this interval. Okay.